Good morning, good afternoon, good evening. Welcome to another episode of Openshift TV. Here we are in the Ask the Product Manager office hours, which is only going to be a half hour today due to some limitations and schedules and such. But we might not need more than a half hour. So I'm going to introduce you to the one and only Mark Curry, product manager here on the Openshift team here at Red Hat. And he's going to talk about IPSec and Openshift OVN, which I think is a really interesting concept. Mark, please introduce yourself to the world and let us know what you're working on, man.
Yeah, great. Thanks, Chris. Yeah, so again, my name is Mark Curry, and I'm an Openshift product manager, and I specialize in container infrastructure elements. And one of those is that of networking. And so today I'm going to talk about a spotlight feature that's part of our Openshift 4.7 release, and that is IPSec. So we did have IPSec in Openshift 3. It was kind of a ragtag implementation, to be truthful. It worked great, but what we wanted to do was we wanted to build in a lot more automation. We wanted to make this operator controlled so there's autonomy with how it is that it runs. We wanted to make sure that it was using a modern level of encryption that would meet FIPS compliance standards. We wanted to add in the ability to be more surgical with the application of IPSec, and we also wanted to build in future support for SmartNICs. So the idea is that IPSec encryption, you will take, it depends on the size of the packet, but you're going to take a little bit of a hit in performance. Thankfully, with OVN, we're hitting near line rate capability of the cards already. So if you just kind of assume somewhere around 10%, that's fair. But what we want to do, and we have a lot of customers asking us for, is the ability to offload that encryption to SmartNICs. And if that's the case, you remove that load from the node onto the NIC and some special purpose chips to take care of that. So we wanted to have all of these things in this new implementation. So there was a bit of a lag before we were able to present it to our customers. But we finally have it available for GA and 4.7. And this is not the end of it. I'll talk about it a little bit. And there's more things that we're going to do to enhance it in future releases that I'll talk about. So cool. Let me back up a bit, a few things. So probably the most important thing to get out of this presentation, and this is that how do you properly spell IPSec? So I know this is just kind of funny for me. I've seen it all across the board. People all uppercase IPSec. People lowercase it. They have up and down cases. Proper case, just FYI, is in the RFC. It's capital IP, lowercase SEC. And so I've tried to do that everywhere. Just trying to spread the knowledge and spread the word.
I appreciate that.
So things will get so we'll talk about some more complex things as we go along. But first things first, right? So one of the things that we have done again in 4.7 is enable IPSec. So what is it? So IPSec, in a nutshell, is the ability to automatically encrypt all internode traffic between pods, data plane traffic specifically, so that traffic is automatically confidential, it's been authenticated, and we know it has not been tampered with. And so application programmers, when they write their traffic and their connections between the pods, and those pods could be spread out across whatever nodes in the cluster, they could write their own authentication scheme, or their own encryption scheme, to do that. However, if you're the cluster administrator, it's probably, first of all, easier and also far more guaranteed to have that traffic secured by just automatically encrypting all the traffic that travels between participating nodes. And so what we also want to do is we want to make that flexible so that when you add new nodes to the cluster, you don't, again, have to think about that. And that's where the concept of an IPSec operator comes in. The IPSec operator actually works with the underlying OVN networking and with Kubernetes to understand when the when the platform has been modified. And when it is modified, like say a new node has been added as part of an auto scaling feature or whatever, then it automatically will bring that node into the encryption scheme and make it a valid participant. So how does this work exactly? So there's a couple of kernel elements involved. So the first one is going to be LibreSwan. And LibreSwan is basically a user space daemon that follows IKE, the Internet Key Exchange specification. And so that's the thing that's actually going to be negotiating the IPSec connection between the different nodes in the cluster. The other element is IPSec itself. And IPSec itself is implemented as XFRM in the kernel itself. Right. And so these two elements work together. And as I've described them, this is actually being controlled by our networking, OVN. I'll explain why in a moment. And it's not just a host level thing that's happening here. And so one of the way we implemented it, this could be, first of all, picked up and placed onto a SmartNIC card in the future, but also by keeping it tied closely to OVN, we can in the future be more surgical with the application of IPSec. So we can say, for example, in the future, not all traffic between nodes, because I don't want all my traffic to take that encryption hit. Instead, I want just these particular namespaces to be encrypted.
Ooh, fancy.
The idea being that we can limit our liability of overhead to just those that require it. And there's more that we can do from there.
Right.
Now, what I've talked about here is really east-west traffic only. But a lot of people ask me, and there are a lot of great use cases for wanting IPSec north-south as well, into and out of the cluster. We have a lot of telco use cases where they are running containerized network functions, and they would like to encrypt that traffic as well for all the same reasons and because of the same, with the same kind of mechanism. They absolutely can, just not the way we've implemented it on day one. So all the elements are there for them to use to do that encryption. It's just not a participant in the east-west operator fueled encryption scheme though, as we've done it. In the future, we will enhance that. And so we're in the stage of, building a design upon the use cases that we've gathered from customers looking for that type of encryption. Currently, IPSec is IPv4 only. However, as of about 2 days ago, Upstream moved IPv6 dual stack to beta. And now that it is beta, that's a really great thing. Now that it's beta, we can support this for our customers, which means in the 4.8 timeframe, we are poised to fully support IPv6 dual stack and single stack. And so as part of that, we want to extend that to OVN IPSec. So again, it was still alpha upstream in 4.7, so we didn't do that, just IPv4 only at 4.7. But in 4.8, we're going to extend that to v6. What else on this slide? So, so the question often comes up, tell me exactly again what traffic is going to get encrypted. So I drew a small diagram on this slide. Actually, I don't have, I'm sorry, let me bring up a slide to show you. I'm looking at a slide and referring to it and just realized you can't see it. So let me share that slide right now.
Perfect.
So on this particular slide, hopefully you can see this.
Yes.
I don't know if my Zoom window over here is blocking the diagram, but let me try to move it. Basically, what traffic exactly is getting encrypted? Well, you have to understand, first of all, that this is internode traffic only. So anything that's using a Geneve tunnel to get from one node to the other. So anything that flows through OVN between nodes. Now, that being said, there's still two networks that are cross node, and there is the actual cluster network, or sometimes just simply referred to as the pod network. That's the one where we have our overlay networking. And then there's the host network, and host networking is literally you're using the networking of the host, which is a different networking scheme. And there's lots of advantages in certain circumstances for using the host network. So this is designed specifically for cluster network internode data plane traffic. So why do I keep emphasizing, first of all, data plane? Because traffic that goes between our control plane nodes and our worker nodes, we don't want to encrypt that. That's already encrypted. And in fact, that's already encrypted with something that is FIPS compliant. So it's using HTTPS for that traffic already. So let's not double encrypt it. Let's not waste time doing that.
Right.
The other part to this is the actual data plane. So that's the part we want to focus on. And so what exactly data plane traffic? Well, I can tell you right off the top that there's really two primary use cases, and then there are side effects. And so I'll get into those next. But the two primary cases is we want to encrypt any pod traffic on the cluster network going between nodes, period. What we specifically are not trying to do is encrypt traffic on the host network pod to pod. That's at the host level, and that's kind of a corner case. There may be somebody that wants to do that, but generally speaking, that's not what people are asking for. However, here's where the side effects come in. So I already talked about how we specifically are weeding out control plane traffic as much as possible because that's already TLS encrypted. But some of the side effects come in when, well, what if a pod is trying to communicate from the host network to the cluster network across nodes, or cluster network to host network across nodes? Well, it turns out that if you're going from the host network to the cluster network between nodes, the traffic actually has to go into OVN on the local side and get Geneve header added onto it before traversing that tunnel to the remote node. And so therefore, that traffic is in fact a participant in the encryption scheme, and that traffic will be encrypted. However, if you're going from the cluster network pod to the host network pod, you don't need to go into OVN on the local side. You can go directly to the host network. And so that traffic is not encrypted. Now, I think those scenarios basically describe any question you might have about, is my traffic encrypted? But one common question that comes up is, what about the API? Is that traffic encrypted? Well, the gotcha here is that there's two APIs. There's the Openshift API that lives on the cluster network. So yes, traffic to and from that particular, internode traffic to and from the Openshift API, that is going to be encrypted. But the Cube API, that actually lives up on the host network. Mm-hmm. So unless you are going from the Cube API to a cluster network pod, that traffic is not going to be encrypted. So I think that describes most of the cases people are interested in. Happy to address any additional questions, but that's kind of the big picture.
So, I mean, there's nothing different from this IPSec implementation than any other IPSec implementation, correct? So it's the security in this IPSec for OVN is just as good as any other security with IPSec, correct?
Yeah, the encryption level and the encryption type that we're using for this IPSec is a very strong AES encryption scheme. Mm-hmm. We talked to the LibreSwan team before implementing it, and they had nothing but good things to say about the particular scheme that we chose, and they recommended it, in fact. And so we have what we feel is the strongest scheme available today that's been proofed, as well as this is something, a very, very big part of this. The primary use case for OVN IPSec was FIPS compliance. So of course, we had to make sure that this was going to be for our customers that required for regulatory or other reasons. We need to make sure that FIPS was being met, and this encryption actually crushes that requirement. So we're good there.
Cool.
So why don't we talk a little bit about how you would actually do this on a cluster? So the first thing I'd like to mention is that today, the way this works is and this came from a FIPS requirement actually, which was it had to be enabled at installation time. Now, for those folks that say, well, I don't want to have to reinstall my cluster just to get IPSec. This is something that we're going to add as an enhancement in the future. So the ability to just enable it, disable it. So you technically could do it now through a more manual process, but I don't think that's in the best interest of our customer. We want to build this into our cluster network operator and have these things automated, so that when all you would have to do is potentially just say, turn it on, and then the cluster network operator would kick off, and it would set up all the certs, and understand which nodes are participants in this, and just do everything for you. And then another thing, which today is actually a FIPS violation, which is FIPS says you should not be able to disable this encryption. But technically, if we enable the ability to turn it on a running cluster, we should be able to turn it off as well.
Right.
So that'll be part of it. But so we give you, we don't dictate, or we're trying not to dictate how it is you implement it and on what clusters. But what we want to do is just provide the functionality, and we want to provide industrial strength security for you right out of the box. So we're trying to be sensitive to that. So how does it work exactly? So if you look over on the right-hand side, those of you who have installed an OpenShift cluster before, this probably isn't too foreign to you. To the new folks, essentially what you can do is when, there's a number of ways you can install OpenShift. One of those ways is from the command line. There's a tool called Openshift Install. And what you can do is just say OpenShift Install create cluster, and it's just a one-liner, and the cluster will come up with a default set of parameters. But what a lot of people choose to do is they choose to pause that installation and add their tweaks to the configuration. And so in this particular case, what we're doing is we're saying pause the installation just for a moment, create the manifests, and then I'm going to go in there and I'm going to edit the manifest that will describe how this installation is going to go. So when we create all the manifests, one of the things that'll make a manifest directory for us, and then we can create a YAML file inside there that describes the IPSec and how it's going to be configured. And so there's a very simple example in there that I provided. So if you were to use your favorite editor to create that cluster network 3 config YAML, you specify your cluster network. You specify any other parameters about this that you would like to customize, and then your service network. And then finally, it's really that last stanza, and in particular, that line that's highlighted in bold red, IPSec config. That's the line that says, I do want to be a participant in IPSec when the cluster comes up. And once you create that file, you add that line in there, you continue the installation. Of course, you can edit anything else before you continue, but you continue the installation, create cluster, and away you go. So what's going to happen when the cluster comes up? The first thing that's going to happen is the cluster network operator is going to create a self-signed certificate. And then any node that comes up as a participant in the cluster, that the cluster network operator, the CNO, is going to create a public-private key pair for those nodes. It's then going to send that public key around the loop to all the other nodes, to the CNO for signing first. It's then, after it signs that public key, it's going to send it back to the original node for distribution to all the other nodes that are active participants in IPSec.
Nice.
So that's kind of the quick and skinny. And then, of course, when a new node joins the cluster, they're going to go through that same process. So the cluster network operator is going to pick up on that, and it's going to implement that same cert sharing and creation. So IPSec is enabled again whenever you update that cluster network operator during installation. And finally, one thing I didn't mention, that IPSec config line in bold red there, the braces there, that's actually today there's really nothing to be specified in there, but quote unquote tomorrow, future enhancements, we want to be able to give you additional configuration items, like, say, for example, maybe you want to specify a different crypto algorithm. Maybe that AES GCM is insufficient, or maybe that gets broken somehow. So we have the ability to change that in the future. And then there's other configurations that we've discussed adding in there, and we're open to suggestions, of course, from customers. And I think that basically is IPSec in a nutshell. So at this point, I'm open to, we have about 10 minutes left or so. I'm open to any questions that folks might have.
So there's a couple questions, but I just want to make a point that it appears our Restream bot that aggregates chat between all the channels is just spamming the channel right now. So please, if you have a question, type it in. I'll try to get to it, and it'll probably be repeated several times. So sorry. So yeah, the one question we got, which I think is interesting, someone requested, well, what about WireGuard, which is also built into the kernel right now in the
Yes.
latest versions. So it'd be interesting to hear your take on WireGuard.
Yeah, so WireGuard is super interesting to me and others in Red Hat. And WireGuard, the only problem is that IPSec is the choice for RHEL 8X. We are heavily considering WireGuard for RHEL 9.
Okay.
And it's at that point that we will make a decision. But know that we have had customer interest about WireGuard. It is very, very interesting, and but it's just not feasible for RHEL 8.
Yeah, no, and I figured, since it just entered the kernel, like within the past 6 months, it'd be a little bit of a longer tail on that, because just because something's in the kernel doesn't mean we can automatically flip it on, right? Like there's a reason you buy Red Hat products, and that's not because it's able to like snap in the bleeding edge stuff immediately, right? There's some stability that we want to get out of WireGuard before we can, fully bake it in.
That's right. Yep. So it's it is definitely something that we're going to heavily discuss for future inclusion. But it's a tough one for RHEL 8 right now.
Yeah. So there's another general question. I'm scrolling back because the Restream bot is being extra special. So let's see. There's a backport of WireGuard for RHEL 8 kernel already, though. Interesting question. Maybe.
Yeah. So the decisions of IPSec versus WireGuard are not, quite frankly, they're not OpenShift decisions. It's these are decisions that are made in the RHEL product side, and I'm not going to speak for the product managers on that side. We have our conversations, and we certainly have our recommendations to them and our use cases that we present. But ultimately, it has to be available and fully supported in RHEL if it's ever going to show up in OpenShift, right? Because we are based upon, all of our nodes are built upon RHEL Core OS, which is derived from RHEL 8. So
Right.
if it's not a RHEL 8, that's a tough one for us to, it's like pushing on a rope. It's a little tough for us to push that.
I love that metaphor, pushing on a rope. It's always great. I envision herds of people just pushing this rope. Is this applicable on hybrid overlay network clusters, Core OS and Windows nodes?
That is a very good question. I don't know that we've actually tested that yet. I don't see any reason why it would not, because Windows nodes basically are built on an OVN connector. I don't, just thinking through the design, nothing strikes me as a obvious blocker for that to work. But I also do not believe we've fully tested that. But that's a very good question.
Yeah. Some thank yous. So apparently we've answered a good question. Apparently, yes. Would be super interested in WireGuard for RHEL 9 OpenShift. Okay, it's not a versus thing, Conan Kudo. It's like either or, right? Right now, IPSec is baked into RHEL 8. We need to get WireGuard baked into RHEL 9 as well. So yeah, it's coming feature. Again, I apologize for all the spam and me trying to sift through it. Making sure we get everything covered. how secure is it? It's as secure as IPSec is. IPSec. Okay, so here's a good one. You mentioned that there was very little overhead, right? I think at first, partly because of kernel and user context switching. Is that a problem here, or is it because it's node to node? It's not going to be too much of an issue?
Actually, yeah, it's the LibreSwan is user space.
Right.
IPSec, of course, through XFRM is kernel space. So there is that element of context switching, but the real that's not where the overhead really is. The overhead is in the actual encryption scheme itself. And for a reasonably strong FIPS compliant encryption scheme, there's just a hit you're going to take when you perform those calculations. It's just a natural part of any encryption scheme. I hate to quote a hard number, but I think it's reasonable to say it's probably somewhere in the neighborhood of 10% for most people. It totally depends on the packet size, right? If you're using huge packets versus smaller packets, that number is going to be different, but probably not vastly different, maybe a few percent difference. But this is one of the reasons why we want to, we wanted to build this, have that ability to make it modular and loosely associated with the host, because we want to be able to pick up this encryption and apply it on some of the smart NICs we're going to support in the future. So some of these have purpose-built hardware who's designed specifically to aid in the performance of encryption. And so, the smart, for example, some of the Bluefield chipsets that are coming out that are part of various vendors, NICs, we want to make sure that we have that as an option for customers. So as those NICs start to become adopted more widely by our customers, that if they make that investment, that they're actually getting a return on the investment for the NIC. They want to be able to offload some of these things like encryption to them to reduce the workload on their hosts. And I suspect that 10% hit will be dramatically reduced if you do that.
Mm-hmm. Yeah, but the whole smart NIC thing is just fascinating to me, right? Like we're starting to get compute on different layers of the stack, and it's just like, my affinity for ARM and just small footprints of compute kind of all over a single server or blade or whatever you're using, right? Like VM, whatever it is, or like that, I think is the most fascinating parts of the future we're looking at right now. As technologists. So yeah, those smart NICs that come along and folks are like, hey, I've got compute available on this network card, right? We've needed it for a long time, and now finally it's coming to fruition.
Yeah. And speaking of smart NICs, there's another roadmapped item we're doing too, which is offloading of OVS itself. So networking in general, we want to have the ability to offload it to a special purpose built hardware designed specifically to improve performance. And so OVS, some of the flow calculations, the encryption, these are all very natural next steps in improving the performance of IPSec.
Cool. And then there's a question about like, hey, we're trying to get Openshift working on like a small system, like IoT device, Raspberry Pi type thing. That'll be sometime in the future. We're working towards that. So it's, trying to get Openshift at the edge is possible now. Getting a full Openshift cluster running on Raspberry Pis, you could probably pull that off, but not easily.
You actually can. You can. There are DIY Kubernetes solutions that run on Pis. I'm particularly interested in that, some of that myself. I look around my desk and that you can't see, and I have somewhere in the neighborhood of about 7 Pis within 2 feet of my laptop.
Yeah,
so I'm definitely
they're all right there, right behind me.
I'm all for having that, but one step at a time. And we are really We work a lot with upstream community to enable these kinds of things, but of course, we're a product, not a project, so we have to focus on the really big enterprise use cases first.
Yeah, exactly. But there's work on the small IoT device front as well going on.
Yeah, absolutely.
So Mark, I don't want to take any more of your time. I know you got to jump to another meeting. If you want to break and I can wrap up here, that'd be fine. And
sounds good.
Yeah.
Thanks, Chris, for
Thank you.
giving me the opportunity to talk about IPSec. And if anybody has any questions, I'm happy to follow up with them.
Yeah, we'll do. I'll send some your way if there's anything. Appreciate it. All right, folks, if you got any more questions, fire them my way. I can definitely get them answered as soon as possible. Lots of enterprises use Raspberry Pi everywhere. Wow, that's awesome, and both crazy at the same time, I feel like. Conan, we should talk more about that, I feel like, and I noticed you're in the Discord, so yeah, like let's have a discussion there, and maybe we can get some more ideas around what you're trying to do and how we can get there. But I totally agree. We need lightweight or lighter weight footprints for OpenShift on certain devices for sure. And that future we are now seeing on the horizon. That future is very much in the coming. So as Mark said, we've got to address the larger use cases first, right? Like whole data centers and things like that. But getting folks out to that edge with OpenShift is a goal of ours. So yeah, let's work on that. And I'll leave it at that. This has been the Ask the Product Manager office hours. We've been talking about IPSec, and if you have any other questions, feel free to reach out to me on Twitter at Chris Short, or you can check our Discord, which I'll drop a link to now. And if you can't join Discord, you can always email me at cshort@redhat.com. So thank you very much, and I will see y'all at noon for an OpenShift Commons briefing talking about centralized policy and governance. So that'll be interesting to think about governance and policy within your organization and how to do it with OpenShift. So we'll catch you then, noon Eastern, 1700 UTC. Have a good one, everybody. Have a great Monday and have a great week. Stay safe out there.